Here's another example of a horizontal bar. Mass big M fixed to an axis at the left end, O, this point right here. The right end is connected to a rope that makes an angle theta with the bar. Write an expression for the tension force in the rope to keep the bar horizontal at rest. Well, we're not dealing with exactly perpendicular situations anymore, are we? So that RF sine theta that we typically put in 90 for the theta, and we take the sine of 90 to be 1, now that's going to be a little bit different. First thing, whenever we have this horizontal bar situation, or even if we go back to that plank thing, or if you wanted to go back to the seesaw, you can use this, I guess it's a trick, I don't know. It's just how I visualize this. Take a meter stick. If you take your hands, move the fingers in together, they are going to find your center of mass. So that's the point where you're going to be able to balance the meter stick. You would think it's going to be exactly at 50 centimeters, but that's not the case. Unfortunately, we have not the best meter sticks in the world. So you've got your center of mass here, and you take it. If I wasn't rushing, then we can have it perfectly balanced and perfectly level. Like that, right? And then if any slight little force acts on one side, it's not level anymore. If I hung a mass from this side, it's no longer level. Now it's rotating about the fulcrum, in which case we're talking about my finger here. If I put a force over here, then that. But if these two torques, the counterclockwise, are equal to the clockwise torques, well, what's causing the torque? There's a little metal tip at the end here. Even if there's not a metal tip, there's still something, some kind of imperfection at either end, and that's why you're not going to have a center of mass at exactly 50. But if the two torques cancel, the clockwise and the counterclockwise, then you're going to have a flat plank. I know you know how these things work and balance because I see you guys all day long messing with these meter sticks. Maybe doing one of these things where you're trying to balance it and figuring out how to get it. Because we're talking about torque, when you are balancing this on your hand, if your hand is not perfectly level, you're going to have an offset center of mass. That's what's going to cause it to fall over. So to get this thing to actually balance, you would need a flat area. The back of the hand is a lot flatter than the palm, and certainly more impressive if you can pull it off. And then you would just line up your center of mass exactly down, so that way gravity is not acting at an angle. That's how you balance things. For more on balancing, go back to center of mass. Previous year. What the heck am I even talking about?